Hi, this is Jim, W6LG for Ham Radio Basics. Welcome to my Radio Room classroom here on Wolf Mountain. These 10 videos are a review of all of the 462 questions that make up the General License question pool. The idea behind the videos is a way to prepare for the exam. I'm going to be reading the question and then the correct answer. And when I can, I'll provide a brief explanation as to why that happens to be the correct answer. So here we go. This is part 8, G8A01. How is an FSK, frequency shift keying signal generated? So it's frequency shift or frequency changing. The answer is B, by changing an oscillator's frequency directly with a digital control signal. It can be done other ways, but the answer is changing the oscillator frequency shift. G8A02. What is the name of the process that changes the phase angle of an RF wave to convey information? In the question pool, when they talk about convey information, they're talking about modulation. So it's phase modulation, B. G8A03, what is the name of the process that changes the instantaneous frequency of an RF wave to convey information? Again, convey information is modulation. Instantaneously changes the frequency, and that's frequency modulation. G8A04, what emission is produced by a reactance modulator connected to a transmitter RF amplifier stage? In this one, reactance modulator is phase modulator, so it's phase modulation. G8A05, what type of modulation varies the instantaneous power level of an RF signal? That is amplitude modulation. So it is a modulation, so its power level. Maybe the best way to think of it is where FM is moving the frequency from. This is the way I think of it: moving the frequency horizontally. If I'm looking at it, amplitude modulation is changing the power level vertically. Maybe that's not a good answer, but the frequency modulation is changing the frequency with the modulation. Amplitude modulation is changing the power level with the modulation. G8A06, what is an advantage of carrier suppression in single sideband phone transmission versus full carrier amplitude modulation? I'm going to read that word for word. What is one advantage of carrier suppression in a SSB phone transmission versus full carrier amplitude modulation? So what's the advantage of SSB over AM? And that is, it's a more efficient use of power. You're not wasting power by transmitting the carrier. G8A07, which of the following phone emissions uses the narrowest bandwidth? Of the ones that are here, this can be, a single sideband can be 2.1 kilohertz, double sideband twice that much, phase modulation 5, frequency modulation 3, 4, 5. The narrowest one that really works is single sideband A. G8A08, which of the following is an effect of overmodulation? Overmodulation, too much volume, and so it's over means too much modulation, so it's not insufficient bandwidth. It has nothing to do with frequency drift, but it is excessive bandwidth. Overmodulation will cause the signal to broaden out. G8A09, what control is typically adjusted for proper ALC setting on an amateur single sideband transceiver? This is one that I talk about all the time on the air. That's how you set the mic gain. That is the way you set the mic gain, not by the number on the knob, but by what the ALC metering is telling you in the transceiver. Okay, G8A10, what is meant by the term flat topping when referring to a single sideband phone transmission? Can be caused a couple of different ways, but it's basically too much drive, so too much drive power. So it's distortion caused by excessive drive, C. Oftentimes the mic gain can be up too high. G8A11, what is the modulation envelope of an AM signal? And it's A, the waveform is created by connecting peak values of the modulated signal. Okay, G8A11, what is the modulation envelope of an AM signal? That's, if you were to look at it on a scope, that's the entire AM signal, and what it's really the peak-to-peak values. So it's from the top to the very bottom of this waveform. So it is A, the waveform created by connecting the peak values of the modulated signal. Not a good question. Carrier frequency contains a signal. No. Sort of true, but doesn't apply here. Spurious, no. Bandwidth of a modulated signal. I can see this one would be confusing, but it's the peak values of the modulated signal. All right. G8B01. What receiver stage combines 14.250 megahertz input signal with a 13.9795 megahertz oscillator to produce a 455 kcif? If you think about how that's done, it's done by mixing. So the answer is a mixer. We're talking about a receiver. So the only one that makes any sense really is mixer. G8B02, if a receiver mixes 13.8 with 14.255 to produce an IF at 455, what type of interference will a 13.345 signal produce in the receiver? I don't know. If a receiver mixes 13.8 with 14.255 to produce 455 IF, what type of interference will a 13.345 signal produce in the receiver? I don't have a clue. It says the answer is an image. I don't know. The frequency that the frequency of the offending signal is at 13.345. The VFO is somewhere else. I don't have an answer for this one. I don't know. It says image response. Don't have a clue. Don't know where that's coming from. I know what an image is, but not sure. G8B03, what is another term for mixing two RF signals? And that is heterodyning. Heterodyning. Goes way back. You could rule out others because cancellation, no. Synthesizing, no. Phase inverting, no. So think of some old receivers, and they were called super heterodyne, for example. G8B04, what is the stage in a VHF FM transmitter that generates a harmonic of a lower frequency signal to reach the desired operating frequency? What is the stage in a VHF FM transmitter that generates a harmonic of a lower frequency signal to reach the desired operating frequency? They say it's a multiplier. I don't have an easy way to answer that one. G8B05. What is the approximate bandwidth of a Pactor 3 signal at its maximum data rate? Well, it's generated at a little over 2 kilohertz, so it's 2.3 kilohertz. All right, G8B06. What is the total bandwidth of an FM phone transmission having 5 kilohertz deviation and 3 kilohertz modulating frequency? They're saying it's the combination of the two, so a total of 16 kilohertz. Both sides. All right, G8B07. G8B07. What is the frequency deviation for a 12.21 megahertz reactance modulated oscillator in a 5 kilohertz deviation at 146.52 phone transmitter? I don't know. It says it's B 416.7. Don't know how to get here from there. I don't have the information, so this is one that I'd have to go research. I simply don't know. G8B08. Why is it important to know the duty cycle of the mode you're using when transmitting? Well, how about to keep things from failing? The answer is to aid in tuning. No, that wouldn't help. B, some modes have higher duty cycles which could exceed the transmitter's average power rating. Well, that's true. C, to allow time for other stations to... No, has nothing to do with that. What it has to do with duty cycle is some modes of transmission require the transmitter to work harder, have a higher duty cycle than others. So it's good to know what that is and to stay well within those limits. Otherwise, you'll be buying some parts, and they won't be cheap. G8B09. Why is it a good match? Why is it good to match receiver bandwidth to the bandwidth of the operating mode? If you think that a signal is 5 kilohertz wide and you're receiving it at 5 kilohertz wide, you end up with less noise. So the answer is D. It reduces it results in the best signal to noise ratio. G8B10. What is the relationship between transmitted symbol rate and bandwidth? Is there a word missing there? What is the relationship between transmitted symbol rate and bandwidth? Well, the higher the symbol rate, the greater the bandwidth. So it's B. Higher symbol rates require wider bandwidths. G8C01. Which of the following digital modes is designed to operate at extremely low signal strengths on the HF bands? I think we all pretty much know it's JT9 and JT65. And I don't know if FT8's on this test, but that's another one that has extremely low signal strength. With an extremely low signal strength, they can still decipher what's coming in. Amazing stuff. G8C02. How many data bits are sent by a signal PSK 31 character? And the answer is it varies. G8C03. What part of the data packet contains the routing and handling information? I don't know. The answer they have there is header. I'm not a packet guy, but so the answer to I could see how some of these would fool you. They would have fooled me. Number B is preamble. I probably would have narrowed it down to B and C, so it's header C. G8C04, which of the following describes baud code? Well, that's a 5-bit code with starts and stops. All right, G8C05. In the Pactor protocol, what is meant by an NAK response to a transmitted packet? So the transmitter sends out a packet, and the response is an NAK, and that is the receiver is requesting the packet be retransmitted. What action results from failure to exchange information due to excessive transmission attempts when using Pactor or Winmore? It disconnects the connection. All right, G8C07. How does the receiving station respond to an ARQ data mode packet containing errors? Its response is to ask for it to be retransmitted B. G8C08. Which of the following statements is true about PSK31? This one I don't know. It says uppercase letters are longer varicodes and thus slow down transmissions. Let's see, A strong. Okay, A doesn't make any sense because it wouldn't. The signal strength is a signal strength. C is to ensure accurate message reception. Error correction. I can see how that one would be confusing. D is just flat wrong. So it's B. Uppercase letters use longer varicode signals and thus slow down transmissions. Not sure how popular PSK31 is these days. G8C09. What does the number 31 represent in PSK31? And that's the symbol rate. G8C10. How does forward error correction allow the receiver to correct errors in received data packets? Because there's redundant information in the data. In other words, the data contains the same information more than one time. G8C11. How are two separate frequencies of a frequency shift keyer signal identified? Well, frequency shift keying by definition is really mark in space, so that's the answer. Don't ever say dot and dash. It's when they're referring to CW. I can see how high and low might be confusing, but in a frequency shift keying, it's a mark and a space. G8C12. What type of code is used for sending characters in a PSK31 signal? And that's that varicode thing again. Varicode.